Okay, so these are the objectives. These comes from the SOLs. We're going to do we already did the multiply. We're going to do the divide. And we're only doing certain kind of divide. There's more to the divide that's in the book that we're not doing. Just trying to keep it as simple as possible. This is the one we did last time, right? We did a product property, which said when you multiply radicals, you can make that one radical of the product. Well, we have a similar property when we divide. A quotient property says that the quotient of radicals, meaning dividing two radicals, could be put together into one radical with the quotient inside. Usually, when you do that, it's almost always because it's going to simplify. If you just put them together, something's going to simplify. And you should, most of the time, you'd be able to recognize. For example, you could see that 32 is divisible by 2. So by putting that all into the same radical, I can simplify 32 divided by 2 is 16. And then the square root of 16 is 4. Right, looking at the second one here, right, if I put that all into one radical, okay, put all that into one radical, right, that's the third root of x to the fourth divided by x. Well, but how does that simplify? X to the fourth over x, that's a property of exponents. How do you do that? I mean, just remember, you got an exponent of 1 there. What do you do with the exponents when you're dividing? Subtract. Keep trying. Okay. So that would be the third root of x to the third. And the third root of x to the third is x. So in the kind of dividing that we're supposed to be able to do, it should be pretty clear that by putting it all under one radical, you're going to get some simplifying, and then at the end, you know, at the very least, you don't have any more radicals in the denominator. Right? When you have a radical in the denominator, then it's irrational. And that's what the SOL refers to here, right, is you got to be able to divide, not requiring rationalizing of denominators. So we shouldn't ever get to the point where we can't simplify and not have any more square roots or radicals in the denominator. Right, here's another divide and simplify. Right, so I would see I'm dividing radicals. So use the quotient property means let's make this one radical and put everything inside. Okay, now, you would assume that 243 is divisible by 3, and you could check it out, certainly. In your calculator, what is 243 divided by 3? It's 81, right? So we've got the fourth root of 81. Okay, now, again, with the properties of exponents, when you're dividing a k to the third over k to the seventh, what are you going to do with the exponents? Subtract, right? And so that's going to become k to the negative 4. Okay, I guess I can do it this way. Now, is 81 a perfect fourth power? How do you use the calculator without making a whole big table, which if you know how to do the x squareds and the x to the thirds, you could do the same thing for the x to the fourths. But what if instead you just take the fourth root of 81 and see whether it works? Remember how we do that again? You go math and 5, right? Math 5 is the x root. It lets you do any root, right? Number 4 is specifically cubed root. If you want to do more than a cubed root, you're going to use math 5, right? And then scroll up to where it says answer, ANS right there, put a 4. And then go back here and do 81, and it's 3. So 3 to the fourth is 81. So we're going to be able to simplify that part of it. And although it looks kind of funny, we can still use remember how we figure out how many k's are going to come out of there? We do the exponent divided by the index. -4 divided by 4 is -1, right? So this is 3k to the -1. And how do we get rid of a negative exponent? Because it always says, you flip it to the other side of the fraction, which makes that 3 divided by k to the positive one. Right? If it's a -1 in the numerator, it's a positive 1 in the denominator. Now, no more negative exponents. So try to do the same thing with that. Try to make it one radical and simplify what you can inside. What'd you get? At the very least, what did you, when you put it all together, how did it simplify? That was the square root of 50x to the 6th divided by 2x to the 4th. Right? So what is that? 25x squared. Right? Which is 5x. Right? The square root of 25 is 5. And then how many x's can you take out? 2 divided by 2. You could take them all out. We don't need to break it up into different x terms or factors at all. It's good like it is. So that's the quotient property. Right? That comes from the tail end of the section 6.2. Right? We did the multiply, but part. We didn't do the divide. But the next part comes from 6.3, which is adding and subtracting. And the thing about adding and subtracting is that you can only add and subtract radicals if they have the same index, meaning the number in the hook right there, and radicand, meaning what's inside the radical is the same. Right? When those two things are true, they're called like radicals. When we combine like terms because this is the same word, like. It means they're the same index, same radicand. That means you can add them up. Called like radicals. Okay. So, I mean, this is the box where they describe it. But when you add or subtract radicals, they got to be the same radical. And then the way that you do it is you add the numbers in front, right? This radical had an A in front, this one had a B in front, so it's A plus B times that. This was a subtract. A times the nth root of x minus B times the nth root of x equals A minus B. Right? It's just like when you added like terms. You did that by combining the coefficients. For example, this one right here, are those like radicals? Are they the same index, and do they have the same expression underneath the radical? What's the index of both of those radicals? It's 2. So they have the same index, and what's inside is the same. So the way you combine them is to, since it's 3 times the square root of 5x minus 2 times square root of 5x, it's 3 minus 2 times the square root of 5x. They call them that distributive property, but in fact, it's more like factoring. You're factoring the square root of 5x in both terms, and what's left is 3 minus 2, which makes how many square roots of 5x? Which makes 1. Right? How about the next one? Can we add them? Say again? Is the index the same? Yes. Is the radicand the same? No. So you can't add them. Right? So when you get something like that, then you can't add them. Right? You're done. Right? So because, well, they've already explained it. Because what's inside is not the same, you cannot combine them. How about the next one? Can you combine them? Do they have the same radicand? Sure, the 7xy is the same. What's not the same? The index is not the same, so you can't add them. Okay. Right, so for 2 different reasons, you can say can't add them. If you can add them, then you add or subtract them by combining the coefficients, right? It doesn't change the radical, right? When we combined 3 times square root of 5x minus 2 times square root of 5x, it's still the square root of 5x. right? Though that doesn't change. It doesn't become like the square root of 25x squared or something like that. It's like 3 apples minus 2 apples, 1 apple. Right? Don't change the radical. Right, try this one. First of all, there's 3 up there. Which one right away are you going to say can't add? Right, this one right here, because they don't have the same index. Right, one has got a 3, one doesn't have anything, which means it's a 2. So this one you can't add. I'll say can't combine because that's the way the book says it, right? That one and that one. But the next 2, they're okay, right? So how do we combine 3x times the square root of xy plus 4x times the square root of xy? You add the coefficients, right? That's 3x plus 4x times the square root of xy, which is 7x. Right? Just combine the coefficients of the radicals. Don't change the radical. How about the last one? They're like radicals, right? They've got indexes of 5, radicands of 3x squared. So combine the coefficients. What do you get? (17 minus 15), 2. So when they're like radicals, it should not be that hard to add them up. Just add the numbers in front or subtract the numbers in front. Okay. The thing is, they're not always, it's not always what you think it is. For example, wait till if anybody's still writing on that. If you look at this one, the square root of 12 plus the square root of 75 minus the square root of 3, you might say, well, I can't do that one, right? Because they're not like radicals. But you can simplify. Each one of those is simplifiable, which means there's a possibility that they actually are like radicals. You just have to simplify it before you can tell that. Now, when it comes to these, simplifying those radicals without just like turning them into decimals, which I know is a challenge for us. On the back of the formula sheet, I've got all the simplifiable radicals, square roots and cube roots. So you'll be able to see once you've got this. I mean, it even shows how you simplify it, not just the answer. So go ahead and if you want to use this in class at least. Wake up. I mean, if we've been simplifying radicals up till now, right? But I mean, that is usually a sticking point. I mean, the square root of 12, you would say, that's not a perfect square. Does it have any factors that are perfect squares? 4. 4 times 3, right? So you break that down into 4 times 3, which makes this 2 times the square root of 3. So if you look on that list I just gave you, it's got that, right? The square root of 12 equals the square root of 4 times the square root of 3, which is 2 root 3. Right. The next one, you could look it up. What's the square root of 75? Don't go down there. It is 5 times the square root of 3. Right? Because you can split up the 75 is 25 times 3. which makes that 5 root 3. And this plus is still in between. And then we have the minus the square root of 3. So now they all are like radicals. They're all the square roots of 3. So how do you combine them? Combine the coefficients. What's 2 plus 5 minus 1? 6. Okay. Okay, here's another one. This one is cube roots. Okay, the cube root of 250. Again, look it up on your sheet. I think I've got that on there. Right, the cube roots are all the way in the right-hand column. The ones above 100 are down below. Do you see the cube root of 250? Right, that is 5 times the cube root of 2. How about the cube root of 54? Plus 3 times the cube root of 2. How about the cube root of 16? Right, a little higher up. 2 times the cube root of 2. Sorry. And now they're all like radicals. Right? How many cube roots of 2 is that? 5 plus 3 minus 2. 6. And then just so we put that in, this is the cube root of 125 times the cube root of 2. This was the cube root of 27 times the cube root of 2. Cube root of 8 times the cube root of 2. Good. You good, Brianna? Jaden? So try to do the same thing with that. It's the last slide. Look up those radicals on the sheet. what did you substitute for the square root of 20? Which is, read all the way to the right. Come on now. The answer's right in front. What is the square root of 20? 2 times the square root of 5, right? All right, what is the square root of 125? Say again. 5 times the square root of 5. Right? So now, there was already some numbers in front of the radicals, so you need to simplify that part. Right? That's 28 times the square root of 5 minus 15 times the square root of 5, which is how many square roots of, sorry, I wrote the wrong thing, which is how many square roots of 5? Square roots of 5 minus 15 square roots of 5. How many square roots of 5? 13. Okay. That's it. We added and we subtracted. We know now you can only do that if they're like radicals. If they're not like radicals, you got to make sure they can't be simplified to be like radicals before you say can't do it, right? And then we added the divide that we didn't do in the last section. 3 things, right? So that's from the last section, 3 divide problems, and then we're going to do all of the ones where you don't have to simplify, 10 through 15. And then these are 3 problems where you're going to have to simplify, but you've got that sheet right next to you. It shouldn't be that hard.